Hello everyone, welcome to my channel. I'm José Cruz, I'm an enterprise architect, and if you follow my channel, you already know that I talk a lot about different subjects, which is common if you work in architecture. If you're not an architect, you can follow my channel, and I invite you to do so and check my videos. I talk a lot of different subjects, and I think you can learn from it. And of course, I'm always learning also, so be free to send some comments. Today, I'm starting a new series of videos which are related with testing, and I will target Locust. It's a Python framework that allows you to do load testing. Why I'm introducing this? Because my future videos, I will be creating some servers and I need some data. And these load testing frameworks are quite useful for that. It's not only to test how your website reacts, but you are sending information to it. So you can develop, let's say, simulations about users sending information to your site, and you can feed your backend with information along the day. You can put a kind of a cron, something like that, or you have a specific rate on the load testing, and you feed data, and then you can check your backends and your tables, metrics, logs, and so on. So it's a way for you to simulate users constantly, and not only just a short period of time to just test the performance or the responsiveness of your website. And that's one of the reasons I'm introducing this Locust first before other technologies for tests. So let's start our Locust. I'll try to be under 20 minutes or 15 minutes. Let's see what we can do. So what is Locust? It's an open source load testing framework in Python. You can develop Python script, you can put whatever you want there, but there are specific things that you should follow so it can do a lot of your work automatically. You can define user behavior, as I was saying, as code, and it's represented usually by a class called HttpUser, and then you create tasks. And these tasks usually they run in parallel, but there are also ways for you to run sequentially if you want. It contains a web UI where you can follow the requests being sent in with nice charts, and we'll see in a moment how it works. And you can scale it, means you can run on your machine, or you can deploy this in several machines, and they coordinate themselves, and you target your website. So you can have multiple sources at the same time. Maybe the reason it's not only about the number of requests that you'll be doing, but you want to, let's say, put in different servers in different places, maybe different clouds or something like that, and target your website, and you can do other types of testing. Imagine that your website wants to check regions and different kind of user engines and things like that. It's always useful if you have different workers in different machines. When I say machines, can be containers, it can be virtual machines, but they run in a different context. Let's say like this. So let's see quite fast the architecture. So what we'll be doing today is we will be just using a runner, which is a master, but as I said, you can also have workers. It seems complex, but it's not. At the end of the day, you install it locally on your machine, the master, or your other machine, of course, and then the other machines you install also, and you just have to tell them where is your master, and that's it, and they automatically it will coordinate. So don't expect crazy configurations, installation of registries, services, and things like that. It is as simple as that. You just need to have open ports between these machines, and when you run it, you have the option, it's not mandatory, to have a local web UI. I'm saying that it's not mandatory because it can be headless. You can run as a command line and export the results, for instance, to a JSON or CSV. But usually when you start the first time, you want to use a UI so you can see what's happening. And then, of course, on this right side, you will have your website. It can have a database or not. It's not relevant. I just wanted for this diagram to be more, let's say, accurate for the real scenario. But at the end of the day, you have a REST API that you want to test. So this is the architecture. In our example, to be fast, I didn't develop a website. There is a nice one. It's called httpbin. If you don't know about it, it's a tiny HTTP playground. It's quite simple. It's just an echo service, and there's a lot of endpoints that you can use when you are starting to develop a client, or you want to test a client against a web server, and you don't want to create yet a web server. And it contains these endpoints that you can use: get, post, put, delete, even delay to add artificial latency. Status is just force a response code. Remember that it just echoes. It doesn't store sessions on their side, nothing like that. It's just for you to send a request and you already know the result. But you can send things and then you receive the response, and you can take decisions about it. And for this kind of load testings and things like that, when you are developing client HTTPs, it's quite nice, because it's not that you are interested in the result of the HTTP bin or the server, but you want to make sure that you are doing what you are sending is being received by the server. That's why the echo is quite nice in this case. And if you want to try just to run curl and you put this and you say that you see the result, maybe I can do it. Why not? I'll just put it here. Let's say curl /https. Okay, let's say httpbin org, and let's say what we have here. It's the okay. We are using the get here. I was forgetting. Let's say hello equals world, and when you run it, and you can see the echo. So and it's a quite nice JSON, because you can get information about what you send. So you send an argument, which is hello world, which is this one. It was the root. This is the host user agent. Here it was curl. Okay, and the origin, this is my IP at this time, and this is the URL that you send. So you can use this information to confirm that your client is working nicely or not. So it's a tiny HTTP playground. If you want, you can visit. I think I have it opened here. If okay, you can see if you go to this website, you can see you have the Swagger, where you have all the APIs. I didn't put all of them here, but you can test them here and use them. It's a quite nice website that you should visit. It can be quite handy in some scenarios when you are testing and you don't want to develop a specific server for your tests. Okay, so let's see how to use Locust. So it's Python, so you should install Python, of course. And then after you install Python, the first thing, it's a good practice in Python, is to create a kind of, let's say, virtual environment. The main idea is that Python use packages to like Node.js and things like that. It's libraries that you want to use on your application. And if sometimes you don't want to pollute your laptop or your desktop with all these packages. You would just, for a specific application, you need a specific setup package. And for that, you create a virtual environment. And the way to create it just like this, you can see here, is this first line. And then you can do it in another command, or you can do in one line. And then you activate. If you are in a Linux environment, you activate like this. If in Windows, you can see the difference. You should use the scripts. And when you do this, you will see that you enter in the command line. You will see that in a kind of a virtual bash, let's say like this, where the packages that are installed for the Python for this specific project will be recognized. And if you exit, they will not be there. And then after you activate, you do the pip install locust. You are not required to use virtual environment. It's just a good practice. If you just want to test and you don't mind about the package installed on your laptop, just do a pip install the Python and use this pip install locust, and that's it. And you want to make sure that the locust installed by doing this locust version, and you should see the result. Okay, now let's see our first load testing, and it is as simple as this. So I'll switch here so you can see this running. So the first one, usually by default, Locust tries to find a Python named locust file, but it's not mandatory. You can create multiple files, you can create suites. Today I'm just introducing, but it can be a big platform with all the things that you can think of. Okay, but for now, let's target just this file. But I will create different files and I will show you how to run different files. So in Python, from locust import, this is class that you need here, and then this is a class. You can see the HttpUser that represents the user. This is wait time. It's a kind of a thinking time. It's like as if the user between the actions is thinking for a while. So it can be between 1 and 3 seconds. And now this is quite important. You have here the task. Okay, and the name of the matter, it's useful for you. We are testing the home of our website. Okay, and you can see self client get, and this is a way to group. It's not important. The most important here, this is the target. This is just a kind of a label that you do. So in your reports, you understand if you have multiple calls and you want to give them a name, let's say shopping cart or something like that, you can put it here. And it is as simple as this. This should run inside. Okay, but I don't see here the target, the number of users. You can configure here, but let's use first the visual. And for us to use the visual, and I'll show you in a moment, okay, here on the slide. So I want to, the first thing you should do is just to run locust, and by default we'll try to find the locust file Python. If you want to explicitly say a different file, I will show you in a moment. And then you will see that it will create a kind of a web server with a page that you can access. And then when we will enter to this local host, okay, and then we'll provide the number of users, the spawn rate, meaning how many users should be incremented between the waiting time for each step, and then you will see the magic happening. So let's write here locust. By default, when you write locust, it will target the locust file. And you can see here that in starting web interface, and this is the local host here. And when I do enter, you can see that it enter on this website. And here you can say, okay, this is our load test, and I want 20 users, okay, 5 at a time, and the host here. Again, we can provide this in a different way, but I want to start with the web first. Okay, now, or here you can provide how much time do you want this for run. If you don't say nothing, it will be indefinitely unless you stop, and you'll see in a moment why. So we start here, and you can see that the number of users are growing. We have edit, we can stop here, but you have these tabs which are quite nice. You start to see some statistics, the number of requests, number of files, what is the median here, the percentile, the 99 percentile, quite important. I will talk about them in a moment, the average of milliseconds by call and things like that. But if you want to more visual, nice thing, when you go to the charts, you can see what's happening visually, which is quite nice for reports if you want to share with your team. So you can see here the total requests per second, how this site is handling our requests. Remember that the request, it's not how much the time, what is the response for the server. It is, of course, correlated with the number of users that you provide, the waiting time that you provide, and the parameters that you enter for the locust. Here you have the response time, how much time is taking to respond the website. Okay, and you have here the 50% of the 95%. This is quite important because this represents the ones that are slow, are the slowest ones. Okay, the usual, these are the good ones. Let's say like this, it's meaning that your server is handling well. But for this, you should check what's happening. Okay, then you have the number of users. We say the maximum was 20, so you see 20. Now you can see if there are failures. We don't have failures. Exception, current ratios here. You can even download the CSV data. I'll show you in a moment. If you click here, you will see a file. You have some logs if you are important related with your application. And now you can stop here. And the server is still running. We can create another one and go from there. But this was the running, and you can see the results about what's happening, and you can take your actions based on what you see. Okay, this is quite simple. You should understand what are the statistics. This is for the one. You should look into these 95 and 99. And of course, in a real website, you have multiple types of these gets and the address and the URLs that you are addressing. And of course, the values will be different, and you want to take actions for one or another. Okay, so let's return to our presentation. So you already know how to start your first one. And the most important thing here, I didn't know if I talk about it or not, it's this task here. These are, you can have multiple here, and all of them will be run in parallel, taking into consideration this and then the parameters that you pass on the user interface. So now what you should do after you check the results, just some tips. I will go more deep this in future videos. Today I just want to introduce. So you check the charts and the statistics, and of course you want to see the requests per second of the number that can be handled by your server. And the failures, sometimes there are failures. I was lucky here. Sometimes even when I use httpbin, sometimes there are some failings being reported. And then you want to check this percentile here, meaning that 95% of requests finish under this time, revealing user perceived slowness. This is the one that you want. So you want to check the address that usually happen and you receive and are under this 95%. So maybe you should improve that on your website. Maybe you can add some cache. Then you should check the code and what's happening. Or maybe it's like that. Right? Maybe it's something that you already know. It's slow, and that's it, because you expect, let's say, a number of requests lesser than the usual. Okay. Of course, you want to see the failures. Of course, you can stop and you can export and it will be quite handy, and I will explain in a moment why. So step by step, if you want a kind of a cookbook, install the Locust, create this file. It will provide you when you run this website. You choose a host, of course, you can start with this one and then move to a real one. You create number of users, how many users do you want to be incremented, and then you want to start, watch the metrics, stop, and you can next try to change the tasks, which is a thing that we'll do in a moment. So let's see now a different approach here. Imagine that we want to test different. We have two different addresses in our server. We have a get and you have a post, and you can see here that you have a new parameter 1 and 3. What this means, it's the weight. It means that this one has a weight of 3 and this has a weight of 1. So one of them will be 3 times, that will have 3 times more requests than the other one. That's what you expect. It's when you have a website, you say, okay, I believe that 80% of the users, they will be searching, only 20% will be doing some introduction of values. And that it will be this case, these scenarios that you want to test with these tasks, okay? And you can arrange as many as you want and provide the weight, and the Locust will handle for you, considering the number of users and the span of the users, how to make sure that this will be accomplished. So another way for you to run, and I will run that in a moment. Let me see. Okay, is as I said before, we can run like this headless run, meaning that you don't want a website to run that. You just rock. This is a way to choose the file. It's with this option. Then you say headless. Now this is the number of users, the number of growing of the users, and the time. This is 1 minute. Maybe you want to put some just a few seconds when you start. Then the host, and then you want the results to be exported here. And that's it. Okay, so let's see now this one running, which is this one. Okay, I will just cancel this. You can see when you cancel, it will export the data for you here, but it's not the best way to do it. So now we'll be using Locust. We'll run this one with this 3 times more than this one. Okay, and we can say Locust 2. Okay, I'm not running Headless, I'm just running a different file. By default, it tries to find this one, but I explicitly say, okay, I just want a different one. Again, we will have a website. We will click it, 20 users, let's say by 5. And let's, okay, and of course the host, httpbin, org, start. Okay, and you can see here that the get is getting 3 more requests than the other one. It's not accurate, but on average that will happen. Okay, there are a lot of files now. Maybe there's a problem with the website, which is quite nice. And you can see here there is a service temporarily unavailable. That's not important for us. We are not testing the real website, but you can see that. Imagine that it was your site, and you start to receive that with a big flow and say, okay, something is wrong. Okay, I know that today this site is having some problems, and other sites also. I check a website where you can find this information. So, but it was quite nice that happened. So you can see what happens when we have failures. So in this case, it's all the requests are failures because this is the same line. It's green and red at the same time. And of course, here the response time will be the same for the 50% and 95%. Okay, but what I want to show you here, it's this request. You can see this usual, this one is 3 plus more than this one. And you can see here the get having 3 more requests than this one on average. It is quite close to it, but don't expect to be really equal. It's not that he has a kind of a cycle that's a 3 1 3 1. It's not, it doesn't work like that because there is the response time also. So, but that's a way for you to start to simulate real scenarios on your website. I have to stop this if the site is down. It's not a good idea to be here. Okay, so let's continue. So you already know how to weight things. If you want to, we can execute this way. Why not? So you can see this working. We'll just stop here. Do a clear. I hope it will work like that. Okay, I will just, okay, not 1 minute. It's a lot. Just 10 seconds. Okay, it can be the Locust file. Why not? It's not a big issue. Of course, there will be a lot of problems to run, and you can see that it's ramping to 50 users at a rate of 10 per second. Okay, 3, let's wait a little bit. You can see the output being here. Now we should see a list of files here that is called first run. You can see here. Why it's called first run? Because if you go here, you can see that we call it first run here. Okay, and this, it will be the prefix of this file. So you can see the exception, the failures, the stats, and history. So if we do a cat on first run, let's say stats CSV, you can see the same information that you see on the website. You go and see failures. Okay, no failures now. Well, nice. Maybe the site it's already and exceptions. No exceptions. Okay, great. It started to work from seconds ago. Okay, so you can see now how to run this Headless. Now, what am I missing here? I just want to show you one more, I think. So let's create a mini project, quite simple. It's very similar, but with more tasks and more real from the point of view of the code. So I want to simulate a tiny product API journey on a public API. So we have a list of categories here, and we have a list of products that you want to simulate. You can adapt to your own. So we have here, add to cart happens once. People see twice as more than add to the cart. It was great if it was like that, but it's not. Probably the view products will be with a completely different weight than this one, not just a double. And then you have the tree here for the random choice of categories, meaning that someone is searching and sometimes clicks and wants to check a category. So we expect 5 requests for this here against 1. It means that every 5 users somehow they will add something to the chart. Okay, I'm not being accurate, can always challenge what I'm saying, because maybe someone got the category and then get the product and click it for add the chart. Of course, I accept that, but just for you to understand the weighting system here. Again, the user can think between half a second and 1 second and a half, and this will be our code. Which is nice is I will post this and we'll say send this JSON here, and this is the name that we are adding. Remember that the HttpBin doesn't care about you send, it will just reply to you as an echo. But again, you understand what you are sending, and now you receive, and you can check, okay, my client is working well, this is the test that I want, the data that I'm sending, it is the real data that later I want to switch to my real server. So my real server should receive this JSON, and I'm receiving back from the HttpBin. If I'm receiving back from, let's say, for me to not enter in big explanations here, let's say the HttpBin works as a kind of a mock website, and you can test, you send information, and it mirrors your information, and you are sure that you are sending the correct information on your load data. It means that if you now target your real website and starts to fail, it means that or the schema that you are using is wrong, or your website is wrong, and you have a baseline to start work from. Okay. So again, it's the same concept. You put in a file, just run Locust. Let's try to 30 users, and then you can use the website, or you can use the Headless. It's your choice. Okay, so I think I have this here on the demo. You can see here, that's the same code that I have there. Okay, the 1, 3 to 1. We can put here a different number. Why not 5 and 10? Why not? And okay, that will be more accurate. So Locust. Locust file demo. Let's run. Now again, 30 users, 10 at a time. httpbin org. This is not broke, right? Start. Let's see some charts. It's growing. Of course, number of requests will also jump. The number of users, of course, it's always 30 because it's the maximum that I provided. The number of requests will grow a lot. And let's see the statistics. And you can see add to the cart 4, but then on the get, you can see 14. This one has 3. Okay, then you have dispose as I said previously, on the average, we should have the number of requests to perform under this weight system, 1, 5, and 10, meaning that for the get category, you expect 10 more requests than the short. So if you can see at the cart 5, and for the get category, that should be this one, get browse, here we have 44. So in time, it will target the right values. Why I'm saying that? Because if you look into it, it's not accurate yet, but on average it will happen, because the reason is the Locust will try to give opportunity when it starts to all the REST API. So it'll start, of course, when it starts, it will not, you don't have a 0.1 request. You cannot start like that. So, and you don't want to perform 10 requests and then you add to the shard, because in a real website, that's not what happens. You want to measure the average of the requests that are happening. Okay, that's why it follows this. But in time, you will see that this one will get to 10 more than this one, and it's reaching if you look into it. Okay, so let's stop. That doesn't, so I will not flow constantly this website for free. Okay, let's return. So we saw this working with a weight different system and more addresses to test. Okay, so at the end, we should read the results, number of requests, which is the traffic volume that we expect. Try to understand this. Usually, probably you should talk with the business person or the architect, saying, okay, what is the number of requests that we expect? They usually, they should know, because when they will be deploying this to a production environment, and the measures of the CPU, memory, the number of instances should be calculated based on the volume of the requests that you expect to receive. Of course, you should check the failures, which are response that are not 200, and the latency, which is quite important. It represents the time it takes for the user to receive an answer, and you want to check these 95 first, and then this one. They are quite critical. One of the things for you that you should do it when you start and you have a good understanding about the users and you fine tune well your load testing, you export to a CSV, let's say a session of 20 minutes or 30 minutes. Then later there are some changes on your website, and then you perform another one, and you can compare the CSVs, the results. So you use one as the baseline, and you see if your website is performing better or not than the previous one. Okay, that's one advantage of the CSV. So common pitfalls that you should avoid. No host set, it's quite simple for you to forget in the headline or even the website. SSL errors, it's something, SSL, it's always a problem. Try to use the verify false to if the site really mandates that you use HTTPS. Use the name. The name, it's the second parameter that we use on the get. So we group things, and it's quite easy if you have dozens of addresses to group them, and you understand them better, and you can find them faster. Okay. Keep tests idempotent. Sometimes it's not easy if you have a quality environment, test environment. Maybe it's not a problem. You just, okay, I don't mind to pollute. I will then restore the databases, everything like that. Otherwise, you should try to create the as much idempotent as possible. So every time you test it, what I say is every time you test, try to have the environment in the same conditions. But as usual, Sam, I'm trying to teach the testers, and they know more about this than I. And of course, start small, get confident with it, and then start to grow until you understand, okay, what is the limitation of my website. So where to go next? Things that you can do. I will create other videos to go more deep on this. I just want to do this introduction. I think from here you can already do great stuff about this kind of tests with just a few lines. But of course, you can add authorization. You can, of course, import the data or generate fake data. There are plugins for that to send to your website, not just requests, empty ones, but you want to provide real data. For instance, maybe you want to perform repetitive data to see if how your application handles if it breaks or not, if you are trying to insert the same data multiple times and things like that. You can even use this kind of platforms, load testing, to test a kind of a functional approach. I don't know if they're the best ones, but you can use them for that. Of course, you can control the requests per second with pacing and shapes, as we did before. It's possible to export metrics to Grafana via plugins. And as I said previously, you can create multiple works to, let's say, to emulate situations where you have users from multiple places, multiple regions, multiple contexts, multiple browsers, if it's important for your website. Sometimes websites, they have different approach for different languages, things like that. So it's sometimes it's useful to have multiple workers at the same time. So we did it. We saw it Locust, we wrote a 10-line user, we ran the web UI, launched your first load, built a mini project, and even we understood how to run using web UI or using the command line. So some of the main features, if you want to know about, or if you start to be interested in this tool, it's a Python first. It's Python. You can do whatever Python can do and put the code as you wish. You have a web UI and headless approach. You can distribute your load for multiple workers, as I was saying. You can shape the traffic by user, spawn rate, constant pacing, and things like that. There are other ways to do that I will show you in the future. You have rich metrics out of the box, very simple to define them. You can do other kind of scenarios like data-driven flow sessions, authorizations, correlations, payloads. You can define step-by-step things. It's possible, not in parallel. Sometimes you want a user to add something to the shopping cart, then now you want to check out, then you want to do the payment, things like that. It's possible to define that using Locust. You can define quality gates on testings, for instance. You can even create something like tags. We only saw the task weights, but the tags, you can have different types of tests, like smoke tests and things like that. And you say, I will test this, and I should have this answer. If I don't, just stop. And I just want to run this subset of tests. Okay, that's why it's on the tasks, by the way. Extensible, you have the possibility to add event hooks, ecosystems. You can even integrate Prometheus and Grafana. And of course, there are other types of clients that you can use, not only HTTP. There are a lot of things that I will be exploring in the future. So when do you want to use it? You want to validate latency, meaning how much time your site is taking to respond to you. Under certain conditions, saturation, CPUs, what happens to the request? Do I receive 500s and things like that? Okay, I'll explore more of this on more advanced videos, but it's what you want to use to check the stress and things like that, how your website reacts for specific conditions that you understand that can break it. Okay, you want to reproduce real use journeys like checkout, for instance. It's possible. The concept of sequential step-by-step exists in Locust, and it's quite simple to implement. And of course, you want to integrate in CI/CD, meaning that we can use the headless to run in a CI/CD. So we don't need the website to run our load testing. Okay, this is also great for capacity planning. Of course, you can imagine why. Okay, you start and you have a specific set of configuration, and then you start with, let's say, 30 users, 100 users, 200 users. You start to grow until it breaks, and you start to understand, okay, and why is breaking? Is taking a lot of time. Maybe it needs more CPU, maybe it needs more instance, maybe it needs more memory. Resilience drills, what happens in a spike? I want to have 10 users, now I have 1,000 for a few minutes, and I want to reduce to 100. What happens? And this is quite common scenarios like logins and things like that, or promotions in sites like Amazon and things like that. Caching, if you want to test with cache and without cache, if you have gains or not. This is one of the best scenarios for load testing. Autoscaling, if it happens or not, and if the autoscaling is fast enough to respond, for instance, to a spike, you can relate this. Rate limiting, multi-tenant fairness, meaning imagine that you have services where some of the users receive a specific API with a specific performance like Netflix, but if you pay more, you have a better experience. And it is, of course, this should be tested with this kind of load tests, meaning you inject users and you see what happens from the response times. Okay, so this is what I want to show you about this great load testing framework. You learn about how to load testing with this simple. There are others, T6 and others, JMeter and others, but I really like this Locust one because the Python is quite fast to do stuff, and you have a lot of libraries that you can put on Python. Can connect to almost everything, and you can take it and just use it for your load testing. And I also use this to feed my website, not for load testing, but to constantly in a specific rate or a random rate to send information to simulate logs, metrics, and other scenarios on my website. So I have a lot of data on my backend that I can explore, and during the development, people can understand what will happen in production. If something starts to fail, okay, now try to find the error. Okay, maybe our log system is not good enough. You can test these kind of things. I think it's a quite nice way to see these things. So this is the first of this series, and I have already a list of things that I want to talk about Locust in the future. So tell me if you like it, drop a comment, something that you want to see about this framework. Thank you for watching. Subscribe my channel, share with your friends. It always gives me motivation to keep going on creating these videos for free. And I hope to see you on my next video.